Welcome back, builders. In video 1, we proved you can run LangGraph locally without paying a cent. This episode is our LangGraph staircase. We will look at smarter state design, safer outputs, and faster parallel nodes. By the end, you will know when to reach for TypedDicts, when to reach for Pydantic, and why LangGraph's send primitive is secretly the performance cheat code. The official course makes a big deal about schema choices, and here's why. TypedDicts give you lightning fast dictionaries with type hints, but zero runtime enforcement. Data classes read nicely, but still do not catch bad data. Pydantic is the one that actually slaps the LLM on the wrist when it wanders off spec. Our goal is to blend them so every state update pays only for the safety it needs. To make this concrete, we are skipping ahead to module 4's map reduce graph. Picture this. Our agent is crafting a comedy reel called Cats. We will ask it for cat-themed subtopics, spin up joke writers for each, and nominate the best punchline. It is playful, it is relatable, and it showcases 3 different state surfaces. The choice of LLM is critical here. Initially, I experimented with a QN3 model, but the results were inconsistent. It would sometimes produce outputs that were not even jokes. That is why I switched to Llama 3.2 1 billion to be much more reliable for this creative task. Check out overall state and joke state in the code. These are TypedDict's lightweight, deterministic, and perfect for keys we mutate ourselves like topic, subjects, jokes, and best selected joke. There is no need to burn CPU validating something we already control. Notice the annotated list with operator.add on the jokes channel. Without a reducer, 2 nodes cannot safely update the same key in the same step. By adding operator.add, LangGraph concatenates every joke that arrives in parallel instead of throwing an invalid update error. This is how we keep throughput high without collisions. Now peek at the Pydantic models, subjects, joke, and best joke. Every time we call the model, we wrap it with structured output. That is the difference between trust me bro JSON and guaranteed fields. If the model forgets a punchline, Pydantic raises an error immediately. So our pattern is TypedDicts for nodes we own, Pydantic for every LLM handshake. The real magic trick is continue to jokes. It returns a list of send instructions, 1 per subject. LangGraph spins those joke writers up in parallel, no extra loops, no scaffolding. When you watch the graph in Studio, you will see multiple joke nodes fire in the same step. Okay, theory is great, but let's see this in action. Here we are in LangSmith Studio with our map reduce graph. I will feed it the topic cats and hit submit. Instantly, the generate topics node fires. In the trace view, we see it output 3 subjects: cat breeds by coat type, cat health issues, and cat grooming techniques. Now watch closely. This is the send primitive fanning out the work. 3 generate joke nodes are running in parallel, 1 for each topic. As they complete, their outputs are safely appended to our jokes list thanks to the operator.add reducer. There are no race conditions, just efficient parallel execution. Once all the jokes are in, they flow to the best joke node, which acts as our reducer, selecting the top punchline. And there we go. Our final output is selected. Now let's go deeper. By switching to the full trace view, we can inspect every step. Here is the output from generate topics. You can see it perfectly matches the subject's Pydantic model. And if we look at one of the generate joke outputs, we see the joke Pydantic model correctly parsed the LLM response. This trace proves our schema strategy is working. The Pydantic models are acting as gatekeepers for every LLM call, ensuring the data flowing through our graph is always clean and predictable, while the lightweight TypedDicts handle the internal state management. And there you have it. We have moved from a simple agent to a robust, parallel, and type-safe workflow. Remember the pattern. Use TypedDicts for your internal state, enforce Pydantic schemas on all LLM outputs, and use reducers with send to unlock safe, parallel execution. This combination gives you the best of both worlds, performance and reliability. In our next episode, we will introduce the final piece of the production puzzle, human-in-the-loop validation, allowing a user to approve or correct the agent's plan before it executes. Thanks for building with us, and see you next time